So this lesson is about solving exponential equations, day 4 and whatnot. Alright, so the key to solving these equations is we have to get like bases. So we already have the 5, so we'll just keep the 5 to the 3x plus 1. And we'll turn this into 5 squared times x plus 1. So this will be 5 to the 3x plus 1 power. And this will be 5 to the 2x plus 2 power. Now that the bases are the same, I can set the exponents equal to each other. So this will be 3x plus 1 equals 2x plus 2. Subtract 2x from both sides, and that's going to give me x plus 1 equals 2. Subtract 1 from both sides, that gives me x equals 1. Problem number 2. I see the base 2 happening over there, so I think I'll shoot for base 2. Now 1/4 is the same thing as, I'm going to do this off to the side. 1/4 is the same thing as 1 over 2 squared. But that's the same thing as 2 to the negative 2 power. So that's what I'm going to put inside of here. So this is really like having 2 to the negative 2 power with an x minus 1 on it. And that equals 2 to the 2x power. Again, if the bases are the same, well, you know what, I'll save that for one more move. So distributing, little distributive property there, I'll have negative 2x plus 2 equals 2 to the 2x power. Now, if the bases are the same, the exponents will be the same. So I can go ahead and set them equal to each other. I'll do negative 2x plus 2 equals 2x. If I add 2x to both sides like this, that's going to give me 2 equals 4x. Now I just have to divide by 4. So that's going to give me x equals 1/2. Alright, so that's the answer to number 2. Alright, looking at number 3. We need these bases to be the same. I'm going to write 9 as 3 squared. Alright, and I've still got that x sitting there. I've already got base 3 to the x plus 2 power. Now that the bases are the same, I can set those exponents equal to each other. So this will be 2x equals x plus 2. Subtract x from both sides, that gives me x equals 2. So looking at number 4, I need these bases to be the same, so I will do this as 2 squared. And I've still got the 3x. And this one I already have the base 2 to the x plus 1 power. Since the bases are the same, well, I guess I could do this. This is 2 to the 6x equals 2 to the x plus 1. Since the bases are the same, the exponents have to be the same. So 6x should equal x plus 1. Subtract x from both sides. That gives me 5x equals 1. Got to divide by 5 to get that by itself. That's going to give me x equals 1/5. Alright, number 5. I've got this base 2, so I'm going to stick with that. So I've got 2 to the x plus 7 power. 16 is 2 to the 4th power, so I'm going to do that. There's my x minus 2. That means I have 2 to the x plus 7 is equal to 2 to the 4x minus 8 power. Now that the bases are the same, I can set the exponents equal to each other. So x plus 7 should equal 4x minus 8. If I subtract x from both sides, that gives me 7 equals 3x minus 8. Time to add 8 to both sides. That gives me 15 equals 3x. Time to divide by 3. So that gives me x equals 5. So let's do base 5. This is 5 to the 3x power, and I can write this as 5 squared. If the bases are the same, I can set the exponents equal to each other. So that's going to give me 3x equals 2. So then I could divide both sides by 3. That's going to give me x equals 2/3. We need the same bases. I'm going to use base 10. So this would be 10 to the x minus 3 power. And this would be 10 squared with my 4x minus 5 there. So that's going to make 10 to the x minus 3 power equals 10 to the 8x minus 10 power. I did the distributive property. Since the bases are the same, I can set the exponents equal to each other. So x minus 3 should equal 8x minus 10. I can subtract x from both sides like this. That'll give me negative 3 is equal to 7x minus 10. I can add 10 to both sides, and that'll give me 7 equals 7x. I can divide both sides by 7, and that's going to give me x equals 1. Alright, number 8. I'm going to have, I'll use my base 3, so that'll be 3 to the x minus 7 power. And 27 is 3 to the 3rd power. And I've still got that 2x right there. So that's going to be 3 to the x minus 7 power is equal to 3 to the 6x. Now that the bases are the same, I can set the exponents equal to each other. So x minus 7 should equal 6x. If I subtract x from both sides, that gives me negative 7 is equal to 5x. Alright, then I would divide both sides by 5. So that's going to give me negative 7 over 5 equals x. Alright, plan on leaving your answers as fractions. Alright, look at number 9. Alright, number 9. Alright, let's go for, well, you know, I can't do base 4 on number 9. Because I can't write 8 as 4 squared or anything. 4 squared is already 16. It's too big. So I'm going to have to change both of these bases. So what I can do is I can write 4 as 2 squared. And I can write 8 as 2 to the 3rd power. That's the key. I have to do them both. So over here I still have that 2x. And over here I still have that x plus 1. So this is going to become 2 to the 4x power is equal to 2 to the 3x plus 3 power. Now that the bases are the same, I can just set the exponents equal to each other. So 4x should equal 3x plus 3. Subtract that 3x from both sides, and I get x equals 3. Alright, let's do number 10 now. We need these bases to be the same. I see this 9 over here kind of doing its thing. I'm going to make that into 3 and some kind of a power. In fact, let me do this off to the side so we don't just choke. I'm just going to work on the 1/9 like we used to do. 1/9 is the same thing as 1 over 3 squared. Does that make sense, sir? Oh, yeah, there he is. Okay, because 3 squared is 9. That's all I did was change the 9 to 3 squared so far. Now, if I wanted to write this as just a base and a power, lost my train of thought. Oh, yeah. So, couldn't I write this as 3 to the negative 2 power and be the same thing? Did you follow that?
Yeah.
Okay. So 1/9 is the same thing as 3 to the negative 2 power. So going back to the original problem, I could just write this down. 3 to the 2x plus 4 power equals. Now instead of 1/9, I'm going to put 3 to the negative 2 power. Okay, I just made that substitution now. Now, I still have this x plus 2 sitting there. So I'm still going to just keep the x plus 2 like that. Alright, the rest is just like all the other problems we've done. So we will have 3 to the 2x plus 4 power equals 3 to the negative 2x minus 4 power. Okay, I did the distributive property. Now that the bases are the same, I can set the exponents equal to each other. So 2x plus 4 should equal negative 2x minus 4. It is time to add 2x to both sides. So that'll give me 4x plus 4 is equal to negative 4. It's time to subtract 4 from both sides. So that'll give me 4x equals negative 8. Wait 1 second. Time to divide both sides by 4. So that is going to give me x equals negative 2. Alright, so that's how you do number 10. Okay. I'm starting the recording again, guys. So, base 2. Maybe you remember that 32 is 2 to the 5th power. So this will be 2 to the 4x. 32 is 2 to the 5th power. Sir, I'm recording. So that's going to be x minus 1. So that's going to give me 2 to the 4x equals 2 to the 5x minus 5. Now that the bases are the same, I can set these exponents equal to each other. So 4x should equal 5x minus 5. I can now subtract 4x on both sides. And that will give me 0 is equal to x minus 5. Then I would add 5 to both sides. So that'll just give me x equals 5. Alright, so number 12. I can see that I've got 9, and then 81 can be written as 9 squared. So I'm going to keep the 9 and do 9 to the 2x power. And then this can be written, 81 is 9 squared, so I'm going to do that. I still have this 2x minus 3 sitting here. So basically what I have now is I have 9 to the 2x. I have 9 to the 2x equals 9 to the 4x minus 6. Now that the bases are the same, I can set the exponents equal to each other. So 2x equals 4x minus 6. If I subtract 4x from both sides, that's going to give me negative 2x equals negative 6. Go ahead and divide both sides by negative 2. Alright, that's going to give me x equals 3. So that would be your answer number 12. Actually, you know what? Alright, on to the back. Alright, this part of the lesson is all about simplifying exponents, but most of this stuff is real simple. For example, in a case like this, am I going to add or multiply? I'm going to add. So this one should be n to the 7th power. That's it. Same thing here. 1p, 3 p's. That's going to be p to the 4th power. That's all it is. Number 3. 3 times 4 is 12. 4 n's, 2 n's, that's n to the 6th power. 3 p's, 1 p, that's p to the 4th power. Number 4. 5 times 3 is 15. 1b, 3 b's, that's b to the 4th power. 6 c's, 4 c's, that's c to the 10th power. Okay? Number 5, this is the type where you multiply. When you have a power to a power, that's when you multiply. So this will be n to the 6th power. Same thing with number 6. Power to a power, you multiply. So this will be x to the 12th power. When you do number 7, you have to actually do 3 squared. So this will be 9, not 6. But it'll be n squared p to the 8th power. Number 8, you should be squaring this. Notice this will be positive 16 because negative times a negative is a positive. But then I multiply, so it'll be x to the 6th power y squared. Number 9, when I do an odd power, negatives will stay negative. So basically, negative 2 times negative 2 times negative 2. That's what negative 2 to the 3rd power really is. That will be negative 8. And then the rest of these I'm multiplying like always. So this will be p to the 12th power and x to the 6th power. Number 10, 2 to the 2nd power is 4. And this I multiply, so that'll be x to the 6th power over y squared. Same thing with number 11. 3 to the 3rd power is 27. Here I multiply, so this will be n to the 6th power, y to the 3rd power. Now the 4, I'm not going to get 12. I have to do 4 to the 3rd power. That is 64. And this will be p to the 15th power. So that's how you do number 11. Okay, number 12. We have to divide. Now the shortcut is to subtract, so we're definitely going to get p to the 3rd power. But please understand, what's really happening is p to the 6th power is like this. 6 p's. P to the 3rd power is like this. So these 3 p's cancel out these 3 p's. I've got p to the 3rd power. Same thing happens right here. So this will be n to the 6th power. It's like 8 minus 2. Okay, but think of it as canceling like this. Number 14. Same thing, but be careful not to get caught up and think you're going to subtract 12 minus 4. The 12 and the 4, we're going to divide those like we've been doing since the 3rd grade. Alright, so 12 divided by 4 is 3. Now with the variables, we're back to canceling again. So these 3 c's are going to cancel out 3 of these c's. So that'll leave c to the 6th. This p is going to cancel out one of these p's and leave p to the 4th power.
You got any tissues? I'm sorry.
In the cabinet. Be careful with number 15. It helps to remember that the long way I've got n, and down here I've got 6 n's. That makes it clear that when these n's cancel out with these n's, the n to the 3rd that's left is on the bottom. And I put a 1 up there to kind of hold the spot. Okay? It's not negative. Okay? If you were thinking negative, you were just doing 3 minus 6. And if you did 3 minus 6, then yes, that would be n to the negative 3 power. But you're not allowed to leave it like that. N to the negative 3 power, again, is 1 over n to the 3rd. It'll be the same thing for number 16. Really, this is n times n over n times n times n times n. These 2 n's cancel out these 2 n's. That leaves n squared, but that n squared is on the bottom, so it's 1 over n squared. Here's my invisible fraction line. Both of these are negative exponents, so they're both going to drop down. If they drop down, that means they're down here. So I have k to the 3rd power, p squared. I'm going to need a 1 up there to kind of hold the spot. Number 18. don't forget, anything to the 0 power is 1. So basically it's like that is gone. Alright? So now 3 over 15, that reduces down to 1/5. I got this n to the 3rd power just sitting here by itself. And these two p's are going to cancel out 2 of these p's and leave p to the 4th power, like subtracting. I'm not going to need this 1 that's in the front. Alright, so I can just erase that 1. Alright, number 19. Alright, so number 19. Same type of thing. We have 6 divided by 2, that's 3. The 5 x's in the bottom are going to take out 5 of the x's in the top. So that's going to leave x to the 5th power up there. The 2 y's in the top are going to take out 2 of the y's in the bottom. So that's going to leave 6 y's in the bottom. Okay, so that's it for number 19. And then for number 20, reduce your 4 over 8. So this is like 1/2. The 1b in the top is going to take out 1 of these b's in the bottom, and that's going to leave b to the 3rd power. The 3 c's in the top are going to take out 3 of the c's in the bottom. That's going to leave 3 c's in the bottom. Now in this case, I need that 1. Alright, if you have a 1 in the numerator and it's the only thing you got, you have to have it. Alright, so that's it for this lesson. I hope it was helpful to you. If so, a like is always appreciated. I will see you on the next video.